Welcome to AP Physics. Today I'll be walking through the brief summer assignment that is intended to make sure you have some of the basic science skills mastered so that your study of AP Physics can focus on the physics and you won't get tangled up on some of the foundational math. If you're having difficulty getting the answers provided in the answer key, then watch how I solve the problems and look for additional resources that I'll link to. Now, let's get started. So let's start with converting a couple numbers into scientific notation. So we start with 21,400. In scientific notation, we know we only want one digit to the left of the decimal point, one non-zero digit. So we are going to start with 2.14. We leave off those zeros because they're not significant. If you have questions about that, I have other videos for significant digits as well as scientific notation, and you can take a look at those. So this is 2.14 times 10 to the something. Well, how far did we move that decimal? It started to the right of that zero. It's implied that it exists there. 1, 2, 3, 4 spots. So this is going to be 2.14 times 10 to the fourth. Our next number, 139.50. We're going to write 1.3950. That zero is actually significant. Again, any questions on that, go check out the other video. 1.3950 times 10 to the. Let's see how many times we moved that decimal. We moved it 2 places. So that's times 10 to the 2. It's a positive 2 because we moved the decimal to the left to make a big number into a number, 1 point. So this is times 10 to the 2. We also know 10 to the 2 is 100. 10 squared is 100, and this is 139, so that makes sense as well. Now we have 0.004600. Well, we want one digit to the left of the decimal point, so that's my 4. So 4.6. And again, these zeros are significant, them being to the right of the decimal. They're not just placeholders. 4.600 times 10 to the. Let's see how many times we moved that decimal place. We moved it 1, 2, 3 spots. So that's 10 to the 3. And we took a very small number, less than 1 number, and turned it into 4.6. So this is actually a negative 3. So 10 to the negative 3, anytime you have a negative exponent, it's a very small number. Anytime you have a positive exponent, it's a bigger number. Next, we want to convert some scientific numbers into standard notation. So 6.54 times 10 to the minus 3. We've got those numbers 6, 5, 4. Now, we start with the decimal here, 6.54. It's 10 to the negative 3. That means we want it to be a smaller number. And so we're going to move it 1, 2, 3 places. And so that's going to make it 0.00654. So that's going to be 0.00654. That is going to be the answer, 6.54 times 10 to the minus 3. 10 to the minus 3 is a thousandth, and so this is 6 thousandths and some more, so that again makes sense. 9.2 times 10 to the 2, we have the digits 9, 2. The decimal starts here. It's times 10 to the 2, so let's move the decimal 2 places to the right. So there's a 0, and that decimal is now here. So that's going to give me the number 920. And that makes sense because 9.2 times 10 to the 2 is the same thing as 9.2 times 100. And that, of course, is going to give me 920. These next problems really require you to use your calculator, to be familiar with your scientific calculator and how it works and how to properly enter scientific notation. So if you're not getting the answers that I provided on the answer sheet, there should be 2 possible reasons. Number 1 is a significant figures problem, and number 2 is how to use your calculator. So let's first take a look at the significant figures. These problems, what we're looking for is to make sure that you understand how to use scientific notation on your calculator, and I have separate instruction on that. The other is understanding the significant digits in calculations, in multiplication and division, and in addition and subtraction. And I'll go into more detail on that in a separate video as well. But let's take this first problem, 3.57 times 10 to the 9th divided by 4.3 times 10 to the 8th. The answer I get if I plug that into my calculator is 8.3023255581. So big crazy number. And that is not the number we're looking for to give this answer if we want it in the correct scientific notation with the correct number of significant figures. So 8.3023, well, the 3.57 has 3 significant digits, the 3, the 5, and the 7. The 4.3 has 2 significant digits. You know that in scientific notation, all the digits that you're showing are going to be significant. So this, we only want 2 significant digits because it's a division calculation. And so the 2 significant digits are the 8 and the 3. So we're going to have 8.3. And in this case, you don't need to say times 10 to the 0, even though that would be really technically scientific notation, but we know that times 10 to the 0 is 1, so we can just leave it as 8.3. So this is okay as an answer, 8.3. Our next problem, 7.65 times 10 to the 4th plus 3.84 times 10 to the 3rd. If you plug this into your calculator correctly, it's going to give you 80,314. Now, how many significant digits? Initially, you might say, oh, there's 4 here, and there's 3 in 7.65, so I need 3 significant digits. Well, that's not technically exactly correct. The reason that we're going to cut it down to the right place is that this is actually 76,500. So this is only to the hundreds place. So we have the 10,000s place, we have the thousands place, and we have the hundreds place. So my answer can't be any more than the hundreds place based upon this number. Here I have times 10 to the 3rd, so this is going to be my thousands, my hundreds, my tens, and my ones place. So the hundreds place over here is as significant as I can get it, so I have to have my answer to the nearest 100. And so if I put this into scientific notation, it's going to be 8.03 is to the nearest 100. And then this is going to be times 10 to the, let's see, 1, 2, 3, 4, times 10 to the 4th. 8.03 times 10 to the 4th. Next problem, if I plug this into my calculator, what I'm going to see is 1085.6. So this is 1.84 times 10 to the negative 3 times 5.9 times 10 to the 5th. In this case, since it's a multiplication problem, I have 3 significant digits here, I have 2 significant digits here, so my answer can only have 2 significant digits. So that's going to be 1 point. Now I'm not going to have a 0. I got to round that 0 up to a 1 because of that 8. So it's going to be 1.1 times 10 to the, let's see, that decimal was here. It's 1, 2, 3. So that's times 10 to the 3. 1.1 times 10 to the 3. And finally, I have a division. With the division problem, I'm going to want to make sure that I have the least number of sig figs in any of the things I'm dividing. So I have 3 sig figs here, 7.34. I have 4 sig figs here, 2.814. If I plug this into my calculator and you plug it in correctly, and we can talk about this if you're not getting this answer, this is what my calculator shows, 3.833787466 times 10 to the minus 3. Well, I have to have only 3 significant digits because of this number, the least number of sig figs. So that's going to give me 3.8, and then it's 3, so that can stay as a 3. And then I'm still times 10 to the minus 3. So 3.83 times 10 to the minus 3. For this problem, this set of problems, we're going to be doing some conversions, and this is a little bit more complicated than some of the conversions that you've probably done in the past. Otherwise, you may be completely familiar with these. But the key here is that sometimes we'll have squared or cubed values that you have to deal with. We're dealing with units on the top as well as units on the bottom that you have to deal with. And some of these are some metric conversions that you just need to be familiar with, as well as kind of metric units. So let's start with 8.2 square meters to square centimeters. So we're going to start with 8.2, and square meters is meters squared. Now, just for convenience sake, sometimes I'll put over 1 just to really emphasize that 8.2 meters squared is on the top, even though it's really not necessary. I like to say times and draw a line. Some people do it with what they call railroad tracks. However you've learned it, you can still do it that way, but this is how I'm going to do it. Now, we want to convert meters squared to centimeters squared. So we know the relationship between meters and centimeters. I don't know the relationship between meters squared and centimeters squared, and I really don't have to. But I know that 1 meter is 100 centimeters. That's something that you really should know. But we're not done because meters and meters squared don't cancel out. But the trick is to get another 100 centimeters over 1 meter, because now meters is on the bottom twice, and that'll cancel out meters squared. And I've got centimeters and centimeters, and that will give me centimeters squared. So the key is to do that conversion twice to get from meters squared to centimeters squared. Now, 8.2 times 100 times 100 is going to give me 82,000. And I wasn't worried about scientific notation or sig figs in this part. And that now is centimeters squared because I've got centimeters, and centimeters gives me centimeters squared. So that's 8.2 times 100 gives me 82,000. Next, I've got 1.45 kilometers per hour. That's 1.45 kilometers over 1 hour. So that's how to think about it, is 1.45 kilometers over 1 hour. Now let's deal with kilometers first. Since kilometers is on the top, I'm going to put kilometers on the bottom. I want to get to meters per second, so I want to get simply to meters up top. And I know that there are 1,000 meters is the same as 1 kilometer. So now kilometers would cancel out. If I stopped there, I would have meters per hour. I don't want meters per hour, I want meters per second. So now, how do I get rid of hours? Well, here, since hours is on the bottom, I want to put hours on the top to cancel it out. And I want to get to seconds, but I don't know how many seconds are an hour, but I do know how many minutes are in an hour. I know that 1 hour is the same thing as 60 minutes. Now I know that hours is on the bottom, hours is on the top, hours cancels out, that's great. Now I would get meters per minute if I just did the calculation there. But I don't want minutes, I want seconds. So now since minutes is on the bottom, I want minutes on the top, and I want seconds on the bottom because I want it to get to meters per second, and this will put seconds on the bottom. I know that 1 minute is the same as 60 seconds. Now minutes cancels out, it's on the top and the bottom. Oh, ignore that. And now I've got, seconds on the bottom and meters on the top, and that's meters per second. So now I'm ready to do my calculation. And when calculating, anything on the top you multiply, anything on the bottom you divide. So this is 1.45 times 1,000 divided by 60 divided by 60. Doing that calculation gives me 0.40 meters per second. My next conversion is 4.5 times 10 to the 5th nanoseconds, ns, to seconds. Now you can look up that conversion. It's one that you may want to know. That nano, I like to say nano is nino. Nanoseconds are tiny. It takes 1 times 10 to the 9th nanoseconds to make up 1 second. So that's the conversion that I'm going for. So I've got 4.5 times 10 to the 5th nanoseconds, and so I'm going to want nanoseconds on the bottom and seconds up top. You could either say that 1 nanosecond is the same as 1 times 10 to the minus 9th seconds, or you can say that there are 1 times 10 to the 9th nanoseconds in 1 second. I'm going to do it where 1 nanosecond is the same thing as 1 times 10 to the minus 9th seconds. Now nanoseconds cancels out, and that gives me a number of 4.5 times 10 to the 5th times 1 times 10 to the minus 9th gives me 4.5 times 10 to the minus 4th seconds. If I've got a minus 9 and a plus 5, that gives me a minus 4. 4.5 times 10 to the minus 4th seconds. My next conversion is 15 grams per cubic centimeter. That sounds like a density to me. So that's 15 grams per 1 cubic centimeter. That's centimeters cubed. Now I can convert grams first. I want to get to kilograms per cubic meter. And so I know the relationship between grams and kilograms, where 1 kilogram is the same as 1,000 grams. So that will get rid of grams, and that would give me kilograms per cubic centimeter, but I don't want cubic centimeter, I want cubic meters. So I need another conversion where I've got centimeters on the bottom, so I've got centimeters on the top and meters on the bottom, and I know that there are 100 centimeters in 1 meter. But that doesn't finish it. I have centimeters cubed, so I've got to do that 2 more times. 100 centimeters is the same as 1 meter. I've got 100 centimeters is the same as 1 meter. And now I've got centimeters cubed, which will cancel out with centimeters times centimeters times centimeters. And I have meters times meters times meters is meters cubed. So now I've got my answer with kilograms in the top and meters cubed on the bottom. When I do that math, I wind up with 15,000 kilograms per meter cubed. Now, this 100 over 1, 100 over 1, 100 over 1, this whole thing, you could write, some people like to do 100 centimeters over 1 meter and then cube that quantity. So that would work, plugging that in instead, but I'm sometimes more comfortable just doing it simply 100 over 1, 100 over 1. Do it 3 times, straightforward, you don't make any mistakes. Finally, I want to convert 3.0 liters into cubic meters. And so I'm going to start with 3.0 liters, and I want to convert it to cubic meters. So I'm going to need some conversion here from liters to cubic meters. Now, this is one that you'll probably be given, or you can, do some other. There's a whole set of strings if you know how to get there from one to the other, and we'll talk through this later on in class when we get to fluids. But we know that that 1 cubic meter is the same thing as 1,000 liters. So 1 cubic meter is going to be 1,000 liters. A liter is actually a cubic decimeter. And so a decimeter, there are 10 of those in a meter. And so it's 10 times 10 times 10 in order to get around the whole cube. And so this will give me, get rid of the liters. And if I divide by 1,000, that's the same as times 10 to the minus 3. So this is 3.0 times 10 to the minus 3 meters cubed. Next, we have some problems about right angle trigonometry. Now, when you know that AP Physics needs trigonometry, don't be thinking, oh, I need law of sines. There's a lot of complicated trig that is really not necessary for AP Physics. So if you just know the basics of a right triangle and sine and cosine and tangent, you're probably there. So let's take a look at this first problem. I want to find out what angle this would be if this side is 3 meters and this side is 6 meters. And so if I take a look at that triangle, what I see is that I've got one side that is way far opposite the question mark, this unknown angle. So this is going to be my opposite side, and this 6 meters is my adjacent side. So if I have a relationship between opposite and adjacent, I know that is a tangent relationship. So think SOHCAHTOA, TOA, tangent is the opposite over the adjacent. So I know that the tangent of the angle is going to be my opposite over the adjacent. And so this, in this case, 3 is the opposite and 6 is the adjacent. So that's going to be 3 meters divided by 6 meters. And if I have 3 meters divided by 6 meters, that's actually going to give me 3/6, or it's going to give me 0.5. So I know that the tangent of the angle is 0.5. If I go into my calculator, I want the inverse tangent. I want to know what angle has a tangent of 0.5. And when I look that up in my calculator by doing the inverse tangent of 0.5, I get my angle, and I write that as theta. That is the common way to write an angle in physics, is going to be 26.6 degrees. So I got that by knowing the relationship of a tangent relationship is the opposite over the adjacent. For number 2, I have an angle, 42 degrees, and I don't know that opposite but I know that the adjacent is 17 meters. So again, it's opposite and the adjacent. Again, it's a tangent. So I know that the tangent of 42 degrees is going to be my opposite over my adjacent. It's going to be my opposite, which I'll just write as OPP for opposite, over 17 meters. Now what I can do is I can multiply the 17 through, and I can get that the opposite is going to be 17 times the tangent of 42 degrees. And when I do 17 tan 42, I get that that opposite side, that unknown, is going to be 15.3 meters. So that's my answer for that unknown. This third one, I have an unknown angle, and I know I've got 10 meters over here and 23 meters over here. This is going to be my opposite because it's the far. This would be my adjacent. And this is my hypotenuse of 23 meters. So I know the relationship between the opposite and the hypotenuse. If I say SOHCAHTOA, I know that the sine of the angle is going to be my opposite over my hypotenuse. So in this case, the sine of that unknown angle is going to be 10 over 23. You could put 10 meters over 23 meters. You see 10 and 23 meters will cancel out. So the sine of the theta is 10 over 23. And so 10 over 23 is going to give me 0.4347. You could just plug it into your calculator. 0.4347, so and so. And so if that's the sine of theta, I know that the angle whose sine is 0.4347. I can do an inverse sine in my calculator and get that my angle is going to be 25.7 degrees. And if you want some help putting that into your calculator, I've got a separate video that will help you with that. Okay, I've got another one. I've got 65-degree angle. I know that 9.4 meters is my hypotenuse, and I've got an unknown. So if I've got the adjacent as opposed to the opposite, this adjacent side is what I'm looking for. And so I need a relationship between the adjacent and the hypotenuse. So SOHCAHTOA, that's my cosine, is my adjacent to the hypotenuse. So I know that the cosine of the angle is going to be my adjacent over my hypotenuse. And so that's going to be my adjacent is my unknown. So let me just leave that as adjacent. I've got that as ADJ over my hypotenuse of 9.4 meters. And that's the cosine of 65 degrees. So I know that the cosine of 65 degrees is going to be my adjacent divided by 9.4 meters. If I multiply both sides by 9.4 meters, I get that the adjacent is going to be 9.4 meters times the cosine of 65 degrees. And that is going to give me an answer of 3.97 meters if I do that in my calculator. Any questions on this? I have a quick tutorial on basic right angle trigonometry.